So today is a heavy calculator day, so if you don't have your calculators, you need to go get them, because as I told you, we're going to be able to do all of our multiplying of matrices on a calculator. So in lesson 3.5, you learned to multiply matrices by a scalar, and today you're going to actually learn to multiply full matrices by themselves, and it's not the way you think it would be. So you're going to learn how to put matrices into your calculator, and then you're going to learn how to pull them up and multiply them by each other. So the first thing you need to realize is that when you're trying to multiply matrices, in this case they ask if you can multiply a 3 by 4 matrix by a 4 by 2 matrix. And to know if you can multiply matrices together, what needs to match up is the columns of the matrix on the left and the rows of the matrix on the right. If those two numbers match, then you can multiply. If they don't match, then you're not going to be able to multiply the matrices together, and your calculator is actually going to yell at you and tell you that you can't do it because the dimensions are wrong. Now, your result, or your product, is going to, and I'm writing with my finger, which is why the writing is particularly bad, but the product of the matrix is going to be the rows of the left-hand matrix by the column of the first-hand matrix. So you multiply a 3 by 4 by a 4 by 2 matrix, and you end up with a 3 by 2 matrix. So yes, you can multiply these two matrices together. And can you multiply a 3 by 2 matrix by a 4 by 3 matrix? You look at these two numbers. If they don't match, you cannot do it. So same thing here. Yes, you could do this one. And down here on the bottom, no, you couldn't do this. And so what you're going to learn is that matrix multiplication is not commutative. In this case, if you look at A and B in these two check your progress, they have the same dimensions, but you can't do A times B and B times A, as you will see in a couple of seconds. So if I were making you do these by hand, here is the process that would happen. And I'm actually going to show you on these two matrices. So I'm going to show you how you would do this by hand, even though you're not going to have to do it, just so you can appreciate the way you do it on your calculator. So if we have 3, 2, -1, and 0, so we have a 2 by 2 by a 2 by 2. And those inner numbers match, so we are going to be able to multiply these together, and then the result is going to be a 2 by 2. I'm actually going to make a lot of room for this 2 by 2. So the first number that we're going to find is going to be 1, 1, and what you have to do is you have to take the first row of the left-hand matrix, this row, by the first column of the right-hand matrix. So for that first slot, you're going to take 3 times -2 plus 2 times 1. And so 3 times -2 is -6, plus 2 is going to give you -4 for that first slot. Now for the second slot in the matrix, you're going to do the first row by the second column. So in this case, you're going to do 3 times 1 plus 2 times -1. And that gives you 3 minus 2, which is 1. For the slot 2, 1, you're going to do the second row by the first column. So you're going to do -1 times -2 plus 0 times 1, and that's just 2, so that would go right there. And then for the last slot, you're going to do the second row by the second column. So this is going to be -1 times 1 plus 0 times -1. And so that's just going to be -1. So doing them by hand, that's how that would work. Now I'm going to show you how to put the matrix into your calculator. And let me first write these down. So go into your calculators, And you're going to see that matrix is right above where it says x sub 1 there on the left, x inverse, which is on the left-hand column. So you're going to hit second and matrix. Now we need to actually put a matrix in, and we're putting in that matrix A. So scroll over to edit and hit enter. Now that matrix A is actually a 2 by 2. It's okay if you have a matrix in here because we're just going to override it. So we have 2 rows, so hit 2, enter, and we have 2 columns. So you're always going to enter it as rows by columns, and then it's going to give you the right size matrix. Now our first matrix in this problem, matrix A, is 3, 2, negative 1, 0. So hit 3, enter, 2, enter, negative 1, enter, 0, enter. Now be sure you always use the negative sign that's down there at the bottom near the decimal point and not the subtraction sign, or else your calculator will yell at you. So there's matrix A. Now we need to put in matrix B. So hit second, matrix, and go over to edit, and we're going to put in, hit 2 or scroll down to B, because now we're going to edit matrix B. It is also a 2 by 2, so that's 2 rows and 2 columns. And the numbers that we have on matrix B are negative 2, 1, 1, and negative 1. Okay, now you need to quit. So hit second, and right next to the second button it says quit above mode. I'm going to clear out my whole screen right now. Now going back to what it said that we're going to do, it wants us to do a R times S. Now the reason I've written these numbers up here is because these are what I've put them in my calculator as. So we're actually going to do A times B. So going back into our calculator, you're going to hit second, matrix. Most time you just want to hit enter because that's going to pull up A. And we want to do times second, matrix, B. So you can hit 2 or scroll down to B. And so when you multiply it out, it'll give you that answer, negative 4, 1, 2, negative 1, which is what we got when we multiplied it by hand. So moving on, close that out for a second. 3 teams competed in the final round of the chess club's championships. For each win, a team was awarded 3 points, and for each draw, a team received 1 point. So which team won the tournament? First thing you need to do is know how you're going to make the matrices. And so the first matrix is just going to be a matrix that's 3 by 2 with the wins and the draws. So 5, 4, 6, 3, 4, and 5. And I've actually saved this in my calculator's matrix C. So you're going to need to go and put these in yourself. And then it says that for each win, they get 3 points, and for each draw, they get 1 point. So you're basically multiplying that matrix by that, because we have a 3 by 2, and we're multiplying it by a 2 by 1. You'll know if you've set these up right, typically, by looking at that inner dimension. Do they match? Yes, they do. So I'm going to go into my calculator, and I'm going to multiply matrix C, by matrix D. So I'm going to hit second, matrix, and I want to pick C, times second, matrix, D. And it gave us 19, 21, and 17. Now, you'll notice that we ended up with a 3 by 1 matrix when we multiplied those together. And so what this means is that the blue team got 19, the red team got 21, and the green team got 17. So the red team would be the winner of the tournament. So knowing how to set these up and organize your information is key. And I'm just going to show you how to set this up. I actually didn't put this into my calculator, but in Thursday night's basketball game, 3 of the players made the points listed below in the chart. They scored 1 point for free throws, 2 points for the 2-point shots, and 3 points for the 3-point shots. So the matrix for this one is going to be 2, 5, 2, 3, 1, 4, 2, 0, 5. And those are the players Wharton, Bryant, and Chris. Now it said for each free throw, they got 1 point, 2 points, and 3 points for the various shots. And so I'm actually not going to put these in and multiply it for time's sake, but that's how you would set up this problem. And when you multiply it out, because you have a 3 by 3 by a 3 by 1, you're going to end up with a 3 by 1 matrix. That'll be your answers. Wharton's score will be on the top, Bryant's will be in the middle, and Chris's will be at the bottom. All right, test of the commutative property. If we have matrix K is a 2 by 3 and matrix L is a 3 by 2, we can multiply those together. Now I've put these in my calculator as E and F. And so let's multiply E by F. I'm going to hit second matrix, and I'm going to select number 5 for E, and I want to multiply that by F. So 6. And we get a 2 by 2, so 5, 10, negative 9, 4. Now what happens if we multiply F by E? So in other words, if we do or L by K. So let's go into our calculator, which is really going to be F by E. And I'm going to hit second matrix, and I want to do F by E. Oh, that looks totally different. So we get a 3 by 3 matrix when we do it the other way. Negative 1, 6, 2. Negative 15, 2, 8, and 1, 2, 0. So going back here, we would get negative 1, 6, 2, negative 15, 2, 8, and 1, 2, 0. Because in this case, you were multiplying a 3 by 2, and you were multiplying that by a 2 by 3. So this said that we could do it, but we ended up with 3 rows by 3 columns. So what this says is that multiplication is not commutative. You can't say that KL is going to equal LK. So the properties that do still apply to matrix multiplication are you can do associative, and that'll still work, and you can do distributive, and that's still going to work. And we've already done the scalar multiplication that we said last section. But commutative is the one that no longer applies when we're talking about matrix multiplication. All right, moving on, we're actually coupling section 3.8 with this because it ties in, and the homework's super easy on matrix multiplication when you're using your calculator. So what we're going to do now is we have solved systems of linear equations algebraically, and now we're going to look at the inverse of matrices and actually solve matrix equations. Now, when you solved the equation that had 3 variables and 3 unknowns, that took a lot of work. When you're using matrices and your calculator, you can very easily solve an equation that has 3 unknown variables. So we're going to talk about an identity matrix, a square matrix, an inverse matrix, a matrix equation, a variable matrix, and a constant matrix. It sounds like a lot, but as you see it, I think it'll all come to light. When we talk about our identity property in math, it's basically what can you multiply a number by so that it equals itself. And so when we're talking about an identity matrix, what can you multiply matrix A by that it will still equal matrix A? Well, that identity matrix, it has to be a square. So you only have an identity matrix for square matrices. And in the case of a 2 by 2 matrix, it's going to be 1, 0, 0, 1. If we're talking about a 3 by 3 matrix, then the identity matrix, or what we can multiply by, is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. Now let's look at why this works. If I'm taking, and we're going to look at it by hand, even though I'm not asking you to do that, if I multiply that times 1, 0, 0, 1, well, you take the first row times the first column. Well, that ends up being A times 1 plus B times 0. Well, that's just A. And then you take row 1 times column 2. Well, that's going to be A times 0 plus B times 1, which is just B. And then you take row 2 by column 1. Well, that's going to be C times 1 plus D times 0, which is just C. And the last thing you would do is take row 2 by column 2. That's going to be C times 0 is 0 plus D times 1 is D. And so that's why these square matrices that just have 1s on the diagonals and 0s everywhere else are our identity matrix. So determine whether X and Y are inverses. Now, what does it mean when two numbers are inverses? It means that when you multiply them by each other, they're going to equal 1. And so in the case of just multiplication, 1/4 and 4 are inverses of each other because when you multiply 1/4 by 4, it's equal to 1. And so in the case of matrices, if you multiply X times Y and it equals our identity matrix, then it's going to work. Now I've saved these matrices in my calculator under G and H. So we're going to multiply G times H. So hit second matrix, and I need number 7. And then I need to multiply by H. So 7 by 8, and see what we get. Oh, that's our identity matrix. So we have to go back and say, okay, well, X times Y is equal to 1, 0, 0, 1. But in order for them truly to be inverses, we also have to check Y times X and make sure that it also equals the identity. And so we're going to look at Y times X, or H times G. So hit second matrix, and we want H times second matrix T. And we get the same thing. So at this point, we can now say that X and Y are inverses of each other because when we multiply them together, we get our identity matrix, which is basically in matrix terms 1. So determine whether P and Q are inverses. So let's first check and see if PQ, does PQ equal our identity matrix? So we want to see if these equal, we want to see if these equal 1, 0, 0, 1. And we have to check both P times Q and Q times P. Well, I've saved these into my calculator under I and J. So second matrix. Oh, I forgot to put these in. So I'm going to now need to edit. Hold on. It's okay. You can see me put matrices in again. So I'm going to go put in matrix, edit, and I want to put it in number 9 for I. And I want it to be a 2 by 2. And I want it to be 3, -1, 4, and 2. Okay, now I need to go put my other matrix in. So I'm going to go to second matrix and go to edit. And this time I want J. And I want it to be 2 by 2. And this one's 1, -3, 2, 4. The more you do these, the quicker you get. So I'm going to hit quit. So I want to check and see if I multiply them together, do I get my identity? So I want to do I times J. And we can stop right there. because when I multiply them together, I don't get my identity. We don't even need to check j times I, because if one of them doesn't equal the identity, then they are not inverses of each other. All right, I think you guys know how to do that now. So find the inverse of a matrix if it exists. I'm actually going to show you the algebraic process, but again, you're going to be doing this in your calculator. So the algebraic process, if I want to find the inverse of the matrix, you're doing 1 over AD minus BC, and you're multiplying that. You're mixing around the matrix and moving A to D and D to A and negating that other diagonal. And so going back, if I were to do this by hand, this matrix is in the form A, B, C, D. So if I'm doing 1 over AD minus BC, well, AD is -1 times -2. BC is 0 times 8. So that's going to be 1/2. And we're multiplying it times our matrix, and we're reversing A and D, so it becomes -2 and -1, and then it's the B and C just become opposites. Well, the opposite of 0 is 0, and then we're going to put -8. So the inverse of this matrix, if I multiply by 1/2, should be -1, 0, -4, and -1/2. So that's how you would do it by hand, but we're not going to do that. So I'm going to put this matrix in my calculator. So S is -1, 8, 0, and -2. So I'm going to, I have to start reusing matrices now. So I'm going to put that in under matrix A. So I'm going to hit second matrix A, and it's a 2 by 2. Oh, I meant to hit edit. So second matrix edit. I'm going to edit matrix A, and it is a 2 by 2, so I'm just going to hit enter and enter. In this case, I want -1, 0, 8, and -2. Then I'm going to quit. Now I want to find the inverse of this matrix. Now that button that we've been hitting to pull up a matrix that says x to the -1, well, that is our inverse button. And so if I want to find the inverse of matrix A, I'm going to hit second matrix. I'm going to pull up matrix A, and then I'm going to hit just that inverse button to say I want to know the inverse of that. And so when I do that, I get -1, 0, -4, -1/2, which is what we got. -1, 0, -4, 1/2. That's what we got when we did this mathematical process to find it. So you're going to use that X inverse button. So we would say that the inverse of matrix X, and this notation is important, is equal to -1, -4, 0, and -1/2. Pretend that that 0 looks like a 0. So in other words, we would say that if we multiply S by the inverse of X, we would get 1. And I get 1. You can test that if you want. You can put in this inverse matrix, -1, 0, -4, -1/2, and multiply it times S, and you will get that identity matrix. So find the inverse of this matrix. You know how to do that now. Put it in your calculator, and then you're going to hit, if you put it in under matrix A, you're just going to hit the X to the inverse button, and it's going to give you the inverse of A. And if it doesn't exist, your calculator will yell at you. And I think that this one doesn't exist. So let's look at what your calculator will do. Because if that denominator, when we did it by hand, the AD minus BC, if that denominator equals 0, you can't do it. And so this, if we have AD, that's going to be 2 times 3 is 6, minus BC is 6. We get 1 over 0, and that's undefined. But if you put this in your calculator, 2163, so go to second matrix, edit, and it's 2 by 2. So it's going to be 2, 1, 6, 3. Now, quit. And let's see what happens when we ask our calculator to find the inverse of matrix A. So here we go. And it got mad. So when it gets mad, you say there is no inverse. It does not exist. So how do we use this? The Booster Club for North High School plans a picnic. The rental company charges $15 to rent a popcorn machine and $18 to rent a water cooler. The club spends $261 for a total of 15 items. How many of each do they rent? Well, the first thing we're going to do is write an equation. And so we have popcorn machine, so I'm going to say that that's P. We have to define our variables. And we have coolers, and we're just going to say it's the number of coolers that they're renting. So we know that they're going to get 15 items. So the first equation is going to be P plus C equals 15. The second equation is going to involve money. And it says $15 to rent a popcorn machine, so 15P, and $18 to rent a cooler, so 18C, and they plan to spend a total of $261. Now we're going to break this into a matrix equation. And so the first thing we're going to look at is what's called a coefficient equation. Coefficient matrix is what I meant to say. And that's basically only the coefficients that are coming before your variables. And in this case, I'm going to go ahead and write them in here. So our coefficient matrix would be 1, 1, 15, and 18. And then we're going to have our variable matrix. And in this case, our variables are P and C. And you have to make sure that you keep them in the order that they were written in the standard form of the equation. P is coming first and C is coming second. So it's going to be a 2 by 1 matrix. And then we put the values that it equals. And that's 15 and 261. I have no idea why I put that line in between those. 15 and 261. So in a way, this is just like any other equation that we've done. We have this number. Let's say we were just doing 8x equals 64. Well, we're essentially multiplying by the inverse of 8 on each side. And this is just a side example. But over here, we need to say, okay, well, what is the inverse of this matrix so that we can cancel it out and only have our variables? So we want to figure out the inverse of 10, 15, 1, 18. And we want to multiply by that inverse on both sides. So go into your calculator, and we're going to go ahead and put this in matrix A to get out of here. So second matrix, second matrix. We want to go into edit. Okay. We have a 2 by 2, and it was 1, 1, 15, 18. So I'm going to quit. So now I want to find the inverse of that. So I'm going to hit second matrix, and I'm going to select matrix A, and then I'm just going to hit the inverse button. So if I want to see that as fractions, and I do, I'm just going to hit math. So I get 6, negative 1/3, negative 1/3, negative 5, and 1/3. So I think now we're actually going to store this matrix so that we don't have to put it in by hand. So I'm going to hit store, which is on that left-hand side. I'm going to store it in a matrix I don't need it. So here's second matrix, and I'm going to store this as matrix B, just so it's right next to it in this problem. So going back, we have 6, negative 1/3, 5, 1/3. So we're going to multiply over here. We have a 2 by 1. And so we want to multiply 15 over 261 by this matrix. So we want to do 15 over 261. That's a 2 by 1. We need to put this matrix on this side. So 6, 5, negative 1/3, 1/3. So basically, we're multiplying by this on both sides, and it needs to be on the left-hand side of each side. So, and that's going to make this side only the variable matrix, and then we're going to get our answer. So if I multiply, I save this one in matrix B in my calculator. I'm going to put this one in matrix C. And it's going to be a 2 by 1. And the numbers are 15 and 261. So 15, 261. And you'll know if you've multiplied incorrectly because it'll yell at you. So I want to do matrix B times matrix C. We get 312. So what just happened is that we multiplied, I'm going to write what we just did in purple. We found the inverse of 1, 1, 15, 18. And we multiplied 6, negative 1/3, 5, 1/3, by 1, 1, 15, 18. Times PC, and that equals, sorry, this is really hard to write with my finger. That equals, we have to do it on the same side for the other side, 6, negative 1/3, 5, 1/3, times 15 over 261. So what our result is that P over C, because this all equals 1, is equal to, and I think it was 9 over 3, 12 over 3, 12, 312. So what that means is that they rented 3 popcorn machines and 12 coolers. So we will do this more in class next time because this is a lot of calculator stuff. I'm just going to give you a couple of problems related to this, and we'll go from there.